You're on what? Yeah. Yeah, we're a little behind. Okay. So, 6-7. Starts on page 433. Pay attention. Ye who has not been here. Ye who is leaving. Don't even start with me. So, what we're going to learn about today is inverse relations, inverse functions. And why do we need to know about inverses? Like, what undoes an addition? Subtraction. They're inverses of each other. They undo each other. Why do we do cube roots? What do cube roots undo? Cubes. So, in math, the beautiful thing is there are things that undo specific operations or specific mathematical things. And so sometimes we actually need to undo in functions. We need to undo a whole bunch of things. So, because we need to do that, people had to come up with inverses. Okay? Inverses are designed to undo things. So let's just do this. Now, relations are a little bit different than functions. Relations are a set of points. Okay? So, for example, if so let's say I give you this set. Ooh, that's a bad squiggly. There, that's better. Let's say I gave you this set. Let's say I gave you 1, 1.2. And 1, 1.4. And I gave you this 0.2 and 1.6. And 2 and 1.9. That is called a relation. It's just a set of points. Okay? Now, a lot of times we want to know, is this a function? So in order for something to be a function, every x value is only allowed to go to one y value. So one way we do this is called a diagram map. So our x values are also known as our domain, and our y values are also known as our range. So we're going to make a diagram map. When you're given a relation, this is what you need to do. So we're going to list all of our x values. So what's our x values that we have? 1 and 2. Don't list them twice. Just list them once. And now let's list our y values.
1.2.
And then we draw arrows. So this x value, what does this x value go to?
1.2.
Goes to 1.2, and then it also goes to 1.4. Problem. And then 2 goes to 1.6 and 1.9. So do you see how the x values went to 2 y values? That means not a function. Okay? But now they might also ask you, well, is the inverse a function? So to find the inverse, all we do is we switch our x's and our y's. Our domain and range flip-flop. So for the inverse, now our domain is anything that was listed under ranges, which is and then our ranges are whatever was listed under domains. You just switch them. You just flip them. And then we draw our arrows again. So 1.2 went to 1. 1.4 went to 1. Is it okay for 2 x's to go to the same y?
Yeah.
And then here. And then here. So is the inverse a function?
Yes.
Yes. Okay, so that was an example I made up. Now let's do the actual example. All right. Peel, I'm sorry I snapped at you, but get your head out of your phone. Wakey, wakey. I know you guys are tired because your plane was delayed and everything. I heard the story. I'm sorry. How'd you guys do at soccer, though? Against?
Thunder Mountain.
That was it? You only play Thunder Mountain? Does JD not have a team?
They won the weekend.
Why don't we just do tournaments up there?
You can't play 4 games in 4 days.
Yeah, you can. A game a day.
That'd be exhausting.
Yeah.
One a day?
Yeah. Like 2-hour games.
You're so
Get all sore headers and they're like.
Baseball, you can do it because you just sit around and don't do anything.
And then you get.
Do I have any baseball players in here?
You can't deny it though because it's true.
It depends what you do.
Depends on your position. If you're catching.
But I do run a lot more in soccer. But if you're a
Run like 10
goalie,
miles a game.
if you're a goalie,
Hey,
Yeah,
Jens
that's
got-
soccer.
Yeah, Jens is
Jens got like 6 guys.
Training
I'm talking about running.
Jens is
Jens is running a lot. He was running slide tackling people out of nowhere.
I respect.
Jens takes it.
But just as in the goalie position, he's a good guy.
Yeah, Max is pretty good.
Exactly.
Like good guy.
Does that say of relation S?
Yeah, they just called it S. They just gave it a name. So this is the relation. And they, like I said, they just called it S. They could have called it. They could have called it silly pants if they wanted. What we need to do now is we need to figure out the inverse of it. So what are we gonna do?
Switch the X and Y values.
Just switch them. So we're gonna say inverse of S. So our X. So we still have X and Y. But instead of 0, 1, 2, or 0, 2, 3, 4, we're gonna under X's we're gonna have -1, 0, 2, and 3. Just flip it. And then over here we have 0, 2, 3, and 4.
So they're both.
And this one, yeah, they both are. I kind of added that in. I don't think they wanted us to talk about that yet, but I figured what's the harm in asking? Might as well go with it. Now, for B, we need graph, but I know you guys don't have graph paper. Some of you do, some of you don't, but that's okay. Don't stress out. Don't let this be the thing that ruins your day. What they're doing is they're throwing this on a graph because they want you to see something. It's kind of cool. So what do you mean? This is cool. Uh-oh. No. No, that's right. Never mind. So this is also a relation, just because it's just a set of ordered points. Right? That's all it is. Just a set of ordered points. So if I was to plot the inverse, so instead of this point being at 0, -1, pay attention! So instead of this point being 0, -1, it's going to be -1, 0. Instead of being at 2, 0, it's going to be at 0, 2. So all you're doing is switching X and Y's, right? So this was 3, 2, so it's going to be at 2, 3. I'm going to show you. This is the cool part, almost. Now this is at 4, 3, so it's going to be at... Now... Oh, Lordy. That's it.
We're recording.
We are recording. Now, here's the cool thing about graphically with inverses. Is if I was to graph the line y equals x, that means it starts at 0, 0, and has a slope of 1, right? It's reflected over this line. Inverse, when you look at it graphically, it's just reflected. It's like I could take this paper, fold it, and they would land on each other. So graphically, that's what inverses do. They reflect it over the line y equals x. Kind of cool? What do you mean? Excuse me?
On my bad day.
You guys are being poopy pants today. Now, here's where we get to the fun stuff.
That just wasn't a mind blower.
I had Mr. Turtle last year.
You ready for this? You guys are not paying attention. I'm going to freak out.
We're talking about math.
Not about my math. When we're done, you can talk about Mr. Turtle or Tuttle or whatever you said his name was.
Mr. Sullivan?
I think he said Turtle.
Yeah, we did.
Be nice to Mr. Sullivan. He's a very nice man.
He taught me all the stuff about geometry.
Okay. So example 2. So now what we're getting into is we're actually getting into finding inverses of functions. Not just relations, of functions. Pay attention. Napoleon, if your head wasn't there, I was going to throw something. I don't have as good aim. I might hit Zane. And then I'd feel bad.
I can just like just stretch.
Okay.
There's a real important story.
So when we did the relation, what did we flip?
X and Y.
Our x's and y's. So when we find the inverse of a function, we're going to do the same thing. We're going to flip our x's and our y's. So instead of a y, we're going to have an x. And instead of a x, we're going to replace it with a y. And now what we're going to do is solve for y. Let's do it.
And that gives you the mirror effect or whatever.
The reflection over the y, or the y equals x line, yeah.
We already know what y equals.
No, I don't. This is the inverse.
Well, we could inverse it.
You're gonna get a
again
different number.
Yeah, can we just inverse it again and then boom? Y
Well, a double inverse is just what we started with.
yeah, exactly. But then you got y equals bam.
I already know what y equals.
So why are we trying to solve for y?
I'm finding the inverse of this function.
It's not the same.
It's not going to give you the same function.
Yeah.
Solve it. What are we going to do?
Minus
Minus
4.
4.
So x minus 4 equals negative 3y. Then what? We don't like negatives in the bottom. So can I absorb it up top?
Yep.
So that means my inverse
X plus.
makes it negative x plus 4 over 3.
Got us on that one.
And this is the inverse.
See, it's a different.
Question.
What?
Will it always, like, you know, the original one you had, you could just divide it by,
No,
it won't always.
don't do it. Just learn it this way. Because we're about to mix it up on you. Okay, so let's find the inverse of this. So wherever I see a y, what am I going to put? An x. And wherever I see an x, I'm going to put a y.
Y.
Now we have to solve for y.
Plus
Add 5. So x plus 5 equals y squared.
square root.
Uh-oh, we just square rooted.
Plus or minus.
This is the inverse. There it is.
Why does it matter if you do, when you move, like, for this one, you move the 5 over?
Mm-hmm.
Does it have to be x plus 5 or could it be 5 plus x?
You can write 5 plus x. Generally speaking, we write it x plus 5.
Okay.
Both work. Is that okay? Okay. The next thing they want us to do is what are the graphs of two inverses? So I need you to get out a calculator, please. Well, it's because people keep taking them and leaving them places. And so I have teachers bringing me them from other rooms.
Not this class.
No, this class. I'm missing calculators out of there, and they keep getting brought to me.
That's your trig class.
No, they don't use them. It is you.
put mine back every time.
I know, but I'm saying some people are not, and they're getting put in other rooms. These are the 4 that I've had brought to me
Dang.
from other classrooms.
Yeah, it's just because I was missing a lot.
So, don't take stuff, because if you keep getting taken, I'm not gonna have any to give you to use, and you're gonna have to get your own. So, figure it out. Learn how to borrow things responsibly. Okay, so here's what we're gonna do. We're gonna graph this, but you notice right here, there's a plus or a. No, we can't do this in our calculator. We can't do plus or minus. So here's what we have to do. So go to your y equals, please.
We're gonna have to do
Just put in
1
2
plus
different
or minus the
equations.
next one. I mean, the first one next plus.
You're right. So the first one we're gonna have is x squared minus 1. And then in this one, we're going to do the positive. So we're going to go square root of x plus 1, close your parenthesis. And then on the next one, we're going to do the negative square root of x plus 1, close parenthesis. So we're going to just do them into y equals. Is that okay? Now, I know I've been doing trig on this calculator, so I have no idea where my window is. So guess what we're going to hit?
Zoom 6.
Zoom 6. So there's the first one. It's a parabola.
That's weird.
And there's the second one.
So the 2 of them together make the parabola, sideways parabola.
Yeah. Why couldn't we graph the sideways parabola as one function? Is it a function?
No.
It fails the vertical line test. So the reason we had to break it up, okay, guys, the reason we had to break it up into plus and minus is it's not, this one right here is actually not a function. It fails the vertical line test. That's why our calculator won't graph it like that. Okay? Now I'm going to do something else. You don't have to do this. So do you see that line? I just put in the line y equals x. If you imagine taking this one and reflecting it, guess where it lands on?
The other one.
It lands exactly where the other one is that we just graphed. It's just got reflected over that line. Is that okay?
So how would we?
It's because it's not a square viewing window. It's a rectangular, so that one side looks stretched. They just wanted you to graph it.
Oh, so we'd have to write down the graph. Or-
Yeah, you just sketch it.
Okay.
Is that all right?
You want us to put y equals x in there? And
No,
combine?
you don't have to. I just want you guys to think it's cooler than you guys said it was. So.
I think that's pretty cool.
That's too cool.
Pretty sweet.
Now you guys are saying that just so I'll let it go.
Pretty awesome.
Okay,
PA.
so
It's kind of a good time.
of course we're going to add on to this. Because would we be happy stopping here? No, of course not. So remember when we talked about x's and y's and I said x's are the
Domain.
domains and y is the range. We're going to bring the idea of domain and range in with inverse functions. Because when we do the inverses, okay, Alex and Roy, I'm about to separate you. Because I know you guys are going to ask me this later. It's going to drive me nutty. Pay attention. So when we did the relation, we switched the x and the y, right? So when we find inverse functions, the domain and the range also switch because we switch our x's and our y's. Okay? So let's start with one. Now with this, we have to think about some things. We gotta remember what we know about certain functions already. Okay? So let's consider this function. Now, we're in the real number system. So, Napoleon.
I'm getting my pencil.
Okay.
Sorry. Thank you. Sorry.
Got it. Thank you. What are we not allowed under square root? Negatives. What's the smallest thing we can have? The smallest thing under a square root we can have is 0. So in your head, so when you see a square root, and I'm gonna ask you what's the domain and range, we got to ask ourselves, okay, it's a square root. What do I know about square roots?
Can I have negative?
Can't have a negative in the real number system, okay? So, what would make this? So, I'm going to say, okay, the smallest I can have, and I'm just writing this down so you guys, smallest under a square root is 0. So, you have to ask yourself, well, what makes this 0? Can you figure that out? X equals
Or 2, yeah.
2.
Negative.
Now, the question is, now I have to ask you, do we get numbers above 2 or less than 2? So
Above.
here's how you can check. So we know that this is going to make it 0. So let's pick a number one way of 2. I don't care. Give me a different number.
-3.
-3. So this is our, so you need to kind of check yourself. So if we said x is -3 and put that in there. What's -3 minus 2?
-5.
Can I have the square root of a -5?
No.
No. So do I want below 2 or above 2?
Above.
So your domain is x is greater than or equal to 2. Is that okay? Now, if the smallest thing under a square root we can have is 0, and we can't have any negatives, what are all our answers going to be coming out? All of our answers coming out are going to be positive numbers. So our range, what's the smallest output we get? 0. And then everything else is going to be positive. So do you see how you kind of have to think your way through that? Okay. So the first thing they wanted from us is domain and range. Now we're going to find the inverse. Now I know this says f of x, but f of x, what can I really say? I could say it's y equals instead of f of x equals, right? Okay. So for the inverse, so this is the function we start with. To find the inverse, what do we do?
Switch x and y.
So it's going to be x equals the square root of y minus 2. Now solve for y. So to undo a square root,
You got square on both sides.
square both sides. So x squared equals y minus 2
+2.
plus 2. So this is my, oopsies, 2. No! So that's my inverse. Now the cool thing about this is because we just found the inverse, guess what happens for the domain and range of this?
They switch.
It's the same as this, but they're reverse. So the domain for your inverse,
Is y is greater than.
you make it x's.
So x is greater than or equal to 0.
X is greater than or equal to 0.
Oh.
Range is y is greater than or equal to 2.
So these numbers right here are what flippy floppy. But we switch x's and y's, so it makes sense that your domain and your range also
Look.
flip. And is this a function? Does it pass the vertical line test?
No.
What is this shape?
Parabola.
Does a parabola pass the vertical line test? Yes, it does. Is it a function?
Sure.
What about the first one? Is that?
Let's graph this. What does this look like? Put this in your calculator.
Can they both be functions?
Mm-hmm.
Can you have a function where the inverse and the normal one are both not a function ever?
You mean both together or one
So,
one
like,
and
you know how you can have something not a function, but we do the inverse. It is.
Mhm.
Can you ever have both of them not be a function?
for the same equation?
Yes.
No, you wouldn't look at it. In pre-calculus, we learned something called one-to-one. I don't know if they talk about it in here. But if something is a function and it has an inverse that's a function, that means every x only goes to one y and every y only goes to one x. It's called a one-to-one function.
Okay.
So we get more in depth in it there.
That's next year then.
Mm-hmm.
Okay.
So what does this thing look like? It should look something like this.
Yes.
So does it pass the vertical line test? How many times did it cross? How many times did it cross? How many times did it cross?
Once.
It didn't cross at all there. That's okay. What's the most times it's going to cross?
Once.
So is it a function?
Yeah.
Yes, it passes the vertical line test. It is a function. So is a function, is a function. Okay? Yes, maybe, kind of. Let's do another one. The function d equals 4.9 t squared represents the distance in meters that an object falls in t seconds due to Earth's gravity.
Oh, you're going part 2.
Yes, I am. Find the inverse of this function. Okay, so let's find the inverse of this. So I know there's d's and t's, but does it matter? No, we're just going to switch them. So instead of d's and t's, to find the inverse, we're not going to have d equal. We're going to make it t equals 4.9 d squared. Can we solve for d? Let's do it. So divide by. Now we're talking about distance, so we are going to square root. So, but do I need to worry about the negative?
No.
No.
There's no negative.
We're not going up. We're falling. So we're not going the reverse direction of gravity. We can't. I'm sorry. So we're going to square root, but I'm only going to worry about the positive because otherwise really does not make sense whatsoever. Are we okay with the inverse?
Yeah.
Okay. Now it says how long does it take the diver to reach the water shown below? Oh, that feels good. In the pic. Oh, I shouldn't have done that. Let me come back to that one. I need you guys not to think about it for a second.
Brain check.
Oh, they do talk about one-to-one. Yay.
Go back.
I'll go back to that one. One-to-one is a big deal. So one-to-one means you have a function and its inverse is also a function.
So that's like what we just had.
So when I say one-to-one, is a function, has an inverse. Okay? Is a function, has an inverse. And one way to tell whether or not you have a one-to-one situation is you use the idea of a composition. So remember we did the f of g? Where it was the f of g of x. We did that the other day. We're going to do that, but we're going to do that with functions and inverse functions. Okay? And if something happens, we're good to go. You ready? So if you take the composition of the inverse and the function, it should equal x. Just x. And it also works if you take the function and the composition of the inverse. Katie, Haley, Alex, Peel. Yes? You're going to have to come in. Because we did that yesterday. So when you take the inverse, when you do a composition of your inverse function and your function, you have to do it both directions, and they equal x. It means we're good. We did it right. Okay, so let's do this. Is this the last one? Hallelujah. Oh, I gotta go back to that. Okay, so let's look at example 6. So we're going to start with f of x. And it's 6 over x minus 2. Oh, this is a fun one. Here we go. So the first thing we need to find is this. This means inverse. F to the negative 1 of x, that means inverse function of f. Okay, that's the notation. That's proper notation. So in order to find the inverse, what do we got to switch?
The y's and the x's.
The x's and the y's. So instead of, so we're going to have x equals 6 over y minus 2. And we gotta solve for y.
Times that one's 6.
I would get, what's the biggest problem right now? Where's y at?
On the bottom.
Ah, it's bothering me. I don't like that at all. So what I'm going to do is multiply by the bottom. Oops, 2. Because what happens here?
Oh, I could.
The y minus 2 cancel. You got to do the whole thing. So over here you have xy minus 2x equals 6. Are we okay to hear?
Mm-hmm.
Some of you guys have checked out. Cole, are you awake?
It was really early morning, and I sat on the tarmac for like 2 hours.
You could have got some good 2-hour nap then.
No.
So let's solve for y. What do we do?
I heard someone broke a chair.
Yeah. Derek got up.
Derek got $300.
And then what? We're still solving for y.
Divide by y. Divide by x.
This way.
Uh-huh.
Would
So
that
X
work the
cancel.
same if you just times it by 6?
No.
No.
At the very beginning.
No.
It's fine. Bring that x and x together.
You got to divide by x, so no. Why did I replace y with this?
Because
you know
that's
it
what
shows
that's the
it's the
inverse.
inverse.
Shows it's the inverse.
That tells me that we have an inverse right now. Are we okay with that? Okay. Now we're going to use the idea of composition again. So now for part B, what they want us to do is they want us to do a composition. They want us to go f of f inverse evaluated at 2. So what's the first thing we always do with these things? When I give you a composition. We rewrite it. F of f inverse of 2. Where do we focus at first? The inside. So we're going to look right here at the inside. So inverse evaluated when x is 2. So then off to the side, the inverse 2. So I take my inverse function, but instead of an x, what are we putting in?
Y.
What?
2. Or what? Oh, sorry, 2, yeah.
2.
Couldn't you simplify the first equation? 6 over x plus 2?
What do you mean simplify it?
Divide by x.
Oh.
Oh.
Wait, instead of writing f of -1, can you just write x?
No.
Now that you're doing the inverse.
No.
You can't do that.
No.
It only goes to the top.
I put it. I replaced it right there. What do you get?
5.
5?
5.
And then what? Instead of f inverse of 2, what am I going to put in here?
F
Here,
of
put
5.
5.
I'm going to put 5. So what we have now is we're looking at f of 5. So now I'm going to go to my f function and replace my x's with a 5. So 6 over 5 minus 2.
2.
2.
I was saying 5 minus 2.
Oh, okay.
We know you can't divide. It's okay.
So
I thought
that's
one
your
that-
answer.
This white always wants to break that down into steps.
I know, I usually do. I tricked him that time.
But this time she just
Keep him guessing.
speed right through.
Let's do another one.
Wait, would it always be that number? Like in this instance, it would be 2.
I don't know. Let's check.
Question. What do you do with that number?
That's the answer.
For what?
This. F of f inverse at 2. It's equal to...
2. I know.
2.
But what do you do with that? What do you use it for?
That's the answer.
Don't do anything.
She decides. She just get a random number and sweet, I got this number.
Uh-huh.
We asked for something.
So where did the 5 come from?
I think it means
Okay. I looked at this. I did the inside first. I put the 2 into the inverse function. I got the 5. So instead of writing f inverse of 2, oh, well, it equals 5. So I replaced this with the 5. And then I did the f function evaluated at 5. Is that okay? Okay. That's your answer. Let's do it again. You know I do this all day. Oh, but they're going to switch it on us. So rewrite it. F inverse of f evaluated at 2. Where do we focus first?
The inside.
D, focus. We focus on the inside first. So the first thing we have to do is f of 2. So to use your f function, so 6 over 2 minus 2.
That doesn't work.
That does not work.
Where'd you get the 2 from?
The question
Syntax error.
does not exist.
So is that no solution for that problem?
That one doesn't work. So to answer your question, does it always just equal that number on the end? Not always. And the problem is because what's the only thing we're not allowed to have in the denominator of a fraction?
0.
What would make that? No, 0. What would make that 0?
2.
What did we try to evaluate it at? The one place we're not allowed to look, and we tried to do it.
Wait, so you can
Not only a whole if they cancel, if factors cancel. This is an asymptote.
So,
You
can
know
you
it's
put
no
any
solution
number
for-
in the evaluation number?
I mean, could I replace this number with anything I wanted? Yeah, want to make one up?
Not really.
Yeah, we do.
Okay, let's do it.
Yeah, we do.
So that's not like some special number.
No,
It's just a number.
give me a number.
17.
Okay. So let's do f of the inverse of at 17.
Good and glorious number.
Really glad you picked that one.
I know.
Should have picked 14.
17 equals x plus
So, where do we look first?
the inside.
The inside.
Yeah, outside.
Josh, don't say it wrong because you think it's funny, because other people in here are not thinking it's very funny, including myself.
My bad.
Josh, you're messing me up.
So,
Stop.
in the inverse function, instead of an x, what do we put?
17.
17. So what do we get?
40 divided by 17.
Oh, it's beautiful. Are we okay to there?
Yeah, that's what
So now we're going to replace the inside. So now we're looking at the function at 40/17. Some numbers are better than others to pick. 17 is generally not a nice one.
you have to pick a number.
I'm just trying to show you it doesn't matter where you're at. Are we okay here?
Probably not nice for anything.
Are we okay to here? So now in my f function, instead of an x, we're going to put
A set of 40 17ths. 34 17ths.
So in the bottom, we need to make common denominators, which is
34 over 17.
so you have 6 over 40/17 minus 34/17. Oh my gosh, this actually turns out nice. Oh, I knew it would. Never mind. Check this out. You guys are going to be mind blown. You ready?
So 6 over 6 17.
So it's 6 over 6/17. Keep the top the same. Take the bottom. Flip and multiply.
Wow.
There's something I didn't tell you.
What?
They're inverses, right? So what do they do to each other?
Equal each other.
They don't equal each other. They undo each other. So what happens if you undo them?
You get the same number.
You get the same number.
All the time.
Except for that one where I showed you it didn't work.
So unless it, you'll get the same number unless it doesn't work.
So unless it cancels out.
So
It
why,
should be the
what's
same
always
number.
know
The
doing
answer,
it?
you don't even have
What's the point of doing this? Is so that you learn how to do compositions and you learn how to plug stuff in. Because in pre-calculus, we don't plug in numbers anymore.
No more plug and chug.
We plug in other functions. So, we make it harder because that's a good time. You know that I skipped example 5? Because it's silly. It was silly pants.
So we're gonna stay on do it. We're not going back to it.
No, we're going to go back to it, but I'm not going to do it how they wanted us to do it because I think it was ridiculous. Let's do it our way. Yay!
After we do, you tell us how this works. Just so we can get
How about I don't try to confuse you? Oopsie, it's the wrong one. Okay, going back to example 5, the one I skipped. They said they want us to solve it and change it up, but they want to know the time that it takes us to fall 24 meters. So instead, what would we normally do?
Just put 24 in for D.
Just put 24 in for D and then solve for T, right?
Yeah.
That's my first instinct. My first instinct is not to find the inverse. So on these ones, I would put that in. And let's solve for T. So what do we do?
Divide by 4.9.
Divide by 4.9.
And then to get rid of the square, we would. Now, am I worried about negative time?
No.
So in your calculator, just put that in, and then there's your answer. Good time. Okay. How do you feel about inverses?
Feel like they
You feel okay kind of finding them?
Yeah.
Like if I give you a function, you could switch x and y and solve for a y again?
Yeah.
Okay. So. Peel that little piece of paper I just gave you. Never mind, I see it on the backboard.
Page 435, 5 through 27 odd. And 440.
Did you guys know I had 2 parts on this one?
Yeah.
Oh.
440, 3 through 29 odd.
Now notice what kind of numbers am I giving you?
Odd, so we can just put them back to book.
Odd, so you can check yourself. Don't abuse the power.
This way. When are we gonna do this?
Cindy, you should not supply them with paper anymore! You guys better give her a nice present at the end of the year because she supplied you with all the paper.
This way.
Don't give her paper because she's at the summertime, fool.